Hi, this is Denisa, and in this video I'm going to go over how to write a program that can find or at least estimate the square root of any positive number without using the math square root function in Python. I've derived this challenge from this website called Codebymath, which is a website which aims to teach code in the context of learning math or vice versa. The website uses Lua, but I'm going to use Python because that's what I'm learning, and I recommend you check out the website. Now, to write a program that can find the square root of any positive number without using the square root function is pretty simple, actually, because you can simply rewrite a root as an exponent. So we can find the square root of x simply by multiplying it by a half. And there you go, you've got the square root of 5 right here. 2.236, etc. But we want more of a challenge than that. So I'm going to use a method that's used to estimate the square root. That's called the Babylonian method. You can find it here in Wikipedia. And it was a method that's used to estimate the square root of a number. So I'm going to need to explain how the method actually works to be able to program it. So let's have an example as given here from Wikipedia, 125,348. To find the square root of that, you will have to go through this process. And to start with, you actually give an arbitrary guess as to what the square root is, and the closer it is to the square root, the better. So here they've guessed 600, and so the next iteration of that is you divide the value of which you want to find the square root for, and divide that by your guess. Add that to your guess, and then multiply that by a half. And then you get a new value. You plug that new value into the same equation, and you do that over and over again until you reach a value of precision that you're satisfied with. So they don't show the full values here, but these probably have decimals of difference, maybe like a 10,000th of a difference. So it's not an exact square root, but as you can see it's an estimate, and that's what I assume Codebymath wants us to find. And we'll try that Babylonian method out. First, coding it by hand here. So S, as it will take Wikipedia's example as well. 1, 2, 3, 4. Not 1, 2, 3, 4, 5, 6. Maybe smaller values. Okay, 100. We all know that's a perfect square, that's 10 by 10. It's always good to have a value you're familiar with, so you can verify straight away if your program is working or not. So this was, we know that the square root is always going to be less than the actual value itself, so we can, half of the value is a good estimate, I think. And then you have x1, where you take that value, and then you take a half, and then you take that value, and then add your original value divided by your guess. And so we can print that out. That's going to be our second value, our x2. Okay, made an error. And it's, as you can see, that's not right. So you need to go further. And you know the square root of 10, the 100 is 10, so we're getting a little bit closer. So let's try one more run. And there you go, it's quite close to 10, and the point of the Babylonian method is that you repeat this as many times as you'd like with your values until you reach a level of precision that's desired. But we're not gonna do that by hand. This is simply for understanding it. And we're gonna write a function that takes an input, which is the number you want to find the square root of, and then we're gonna print out what the square root of that input is. And we're gonna start like this. So s, we'll just take 100 again, to be honest, really. And then same, but this time we're going to automate the process. So we're going to have a variable that's called difference, which is going to be used in a loop to calculate the difference between the first value and the next, so that the computer will eventually know when to stop and when the estimate that they calculated is precise enough. And we're gonna have a variable for accuracy. Let's say some arbitrary value, 0.01. That's how much you want your decimals to differ. So if we found if we wanted to find the square root of 100 using this method, you might have 10.81205. So eventually, when it gets to 10.000002, it'll stop. And it'll say, okay, 10 point etc etc is a rough estimate for square root of 100. So we're gonna write a while. And this is gonna make sense in a bit. So as long as the difference between two values x0 and x1 and x2, etc., is larger than this value of accuracy that you want to achieve, it's going to keep calculating these formulas. So let's put it in. X1 is 0.5 multiplied by x0 plus s divided by x0. And then to calculate the difference between your values, you're going to have x0 take away the new value x1. And then you're going to set your old value into your new value, and then you're going to calculate the new value and then calculate the difference and so on. And then once it stops, once it detects that the difference between x0 and x1 is less than this value, it's going to print what the square root is. Let's test it out. And there you go, it actually is pretty accurate. We can try that with a larger value. Say 1, 2, 3, 4, 5. And there you go. If we made that accuracy a little bit less, maybe you can see the difference. It's actually still pretty accurate. You can as you can see, you can see the difference between those decimals. Okay, so we're gonna make this a function which takes input from the user, so the user can type which which number they want to find the square root for. So square, we're going to define a function called square root, and it's going to take the value, it's going to take an input that's called s, which is the number you want to find the square root for. And then it's going to return the value of x x0. That's the calculated root that they found. I'm gonna make this accuracy a little bit smaller again. And so the program's gonna ask, then we're going to turn the input that the user gives into a number so that it can be calculated inside the function. I'm gonna say find the square root of, and then we're going to take that input and say the square root of a number is and then you're gonna have x0. And it's supposed to also put an input. Okay, let's find the square root of 100. Okay, we made an error there in the concatenation. Oh, of course. Yes, you have to actually put the function there. Square root number. So that's the input they asked for. Find the square root of 100. The square root of 100 is See, it actually gives, see, when it prints out the value as a string, it actually gives all the decimals, so we can easier see the accuracy. Let's make this a bit bigger. And the square root of 100. There you go, it's more accurate. We're gonna make it less accurate so it's easier in the computer to calculate. And then the one problem you might find with this is that you can actually input negative value. You will be able to input 0, and you don't want that. So to prevent that, we'll write if the input is less than or equal to 0, we'll write no, we don't like that, invalid input. And if else, it'll print the value. So you can say 100, and if you give it a 0, for example, you'll say invalid input, not right. And if we gave it a negative input, which isn't a real number, it'll say invalid input as well. And there you go. That's how you write a program that can find the square root of any positive number without using the square root function. Obviously, this is an exercise in programming. These methods aren't exactly efficient. It's much better to just use a calculator or write it as an exponent. But there you go. That's how you do it. Thanks for watching, and go check out the website Codebymath.